Okay, welcome back again. This is the Chipmaster. In this video series, I'll be doing another laptop repair here on a Dell. I got it from a tech and he said that it's turning on but no image or no display whatsoever. Right, it's a Dell inspiron. I'm not sure of the model. Right, so he said that it's not turning on. It's turned on but it's not displaying anything. So I'm going to see if I can repair it. Okay, so I'm going to plug in the power. Alright, so I'm pressing the switch. As you can see there, I have 590 milliamp, 700 milliamp, 800 milliamp. I have a solid caps lock light here, as you can see. 600 milliamp, 760 milliamp, 820 milliamp, and still has no image. Let me get the keyboard to see if I have caps lock on the that indicates that the laptop is actually posting. All right, so I'm gonna go ahead, give power again. Hold on. Not getting any caps lock. There's nothing. Alright, so that indicates that I'm definitely not getting a display. Alright, so I removed the battery. So I'm going to check for visual appearance inspection. Alright, so we have the standby over here. I believe this is 5 volts. All is well there. This is could be RAM supply, or it could be 3.3 volts. All is well there. Just some dust. Alright, in the CPU power supply section here. Alright, these are the core supplies for the CPU. Alright, so this is the charging coil. All is well. Everything seems fine there. Alright, the VCC GT, the integrated graphics supply. Everything is okay in this section. All is well there. Alright, everything is good on this side. Alright, continuing the disassembly. Alright, so the motherboard is out. Alright, so now I will flip over to the other side. Alright, so another visual inspection again. Alright, so here just some dust. There's no components on the side of the board. Alright, here is just some dust, hardly any components. Alright, so I'm going to look under the sticker. This should be the embedded controller. Alright, all is well there. Alright, the audio section here, just dust. And this is the other side here, just having some dust. So I'm going to remove the dust. Alright, dust is now removed. Alright, so I will get the DC jack. Alright, so here we go. So first, I don't have to check resistances because the laptop is already powering on. All I need to check for is voltages. Alright, so I'm just going to check for voltages. So I'm going to strike the motherboard. Turn it on. There we go. So I'm going to check this side. Should be 3.3 volts or 5 volts. We get 3.3. This is 5 volts right here. Right. This is RAM supply, 1.2 volts. Excellent. Alright, so next I have VPP. VPP 2.5 volts. I can check under the RAM, so it doesn't really matter. Okay, so I connected the switch, so I don't have to use the meter every time to trigger the board. I just press the switch. Now I'm going to press the switch. I believe my ports are sometimes slack. Alright, so I'm turning on the board again. Alright. Oh, sorry, I need to check VPP power supply, so I have to move the RAM to check the VPP power supply. Alright, so I'm going to give power again. Alright, VPP 2.5 volts. Yes, I have 2.5 volts there. VPP 2.5 volts is okay. Alright, termination supply 0.6 volts. Yes, 0.58, so termination supply, and the voltage reference is also okay. Alright, CPU core 1.1 volts, that's a bit high. The CPU voltage should be adjusted to 0.8 volts, right? After the CPU gets the PLT reset signal, right? The PLT reset signal will be issued to the CPU. The CPU will now start to decode the CPU power supply through the SVID to tell the CPU core supply that to output the correct voltage and current, right? So this is a dynamic adjustment through the SVID clock and SVID data. Right, so I'm getting 1.1 volts here, so this voltage is incorrect, right? So there's no decoding, right? The CPU core supply doesn't get the instruction, so this is called VBoot voltage, right? VBoot, right? Because the voltage that is generated is a free voltage that is generated at a fixed supply for a few milliseconds. After the CPU gets the PLT reset signal, then it will send this SVID command through the VI SDK clock and VI SD data to adjust the CPU core output voltage, and it will dynamically adjust it to 0.8, 0.7, 0.9, and it will automatically start the IMVP, which is the Intel voltage mobile positioning, right? So this is the specification which was implemented from back in Intel Series 5, right? Which is the Irondale CPU from the first generation CPU of the Core series. All right, so there's no voltage here because, as you see, I'm getting 1.05 volts here. This is abnormal. I should not be getting any voltage here. This indicates to me that the CPU, the graphics card in the CPU, is most likely faulty. First of all, let me check if this is an AMD platform or not, because that's not a correct. I should not be getting any voltage there. So let's check if this is an Intel. That's abnormal. I should not be getting any voltage there if it is an Intel based board. If it's AMD, there we go. So that's why it's getting that voltage, because it's an AMD platform. So this doesn't use. So this voltage is correct, right? So for the AMD, this is correct. If it was for the Intel, that will be too high, right? So automatically I realize that this is not an Intel board because the voltage should not be here. This is for the graphics. This is the core supply. For the Intel, the only time you get voltage here is when you're playing a game or watching a movie. All right. So based on the current, I know that the CPU is running code, right? So I will do a BIOS program. So I'm going to remove the BIOS. First, let me remove the heatsink so I don't thermal shot the CPU. Don't want to thermal shot the CPU, so I'm removing the heatsink. Oh, my temperature was way low. Okay, so I'm now on the Dell website here. So I'm going to download a BIOS for this model. So I have the model here, which is a Dell Inspiron 3505, right? So I will download the firmware for this file. All right, so I hit drivers and downloads. Right, so I'm going to select drivers. Right, so I need the BIOS. Alright, here it is. So it's a Dell 3505 or an Inspiron 3505. Alright, so I'm gonna download this one. I'll save it to the desktop here for now, or to the Dell extractor rather. Alright, so this is an inside BIOS, as you can see here. So this is an inside BIOS, so I don't need extraction here, so I can just put this back to the desktop. Alright, so I'm going to create a new folder and I'm going to call it Dell Inspiron. Did I switch over to my? Okay. So it's a Dell Inspiron. Alright, I will just drag this back in here, and I forget to give you the part number or the board number. Okay, so I've now extracted the BIOS. Right, it was a bit tricky to extract, right, because it wasn't created with Python, right, so I had to use a different extraction tool, 7-zip, to extract this file. All right, so as you can see here, I have my backup file. I have this is a 26 megabyte file here, right, and it's just have a file extension of file, right. So I'm going to open my backup. All right, I'm going to drag this also into the WinHex. All right, so this is the downloaded file, and this is my backup file. Right, good. So I am going to, as you can see, my backup file starts with FFF, and the ending part is the 9090 E96B. This is the ending part of the BIOS, right? So my total BIOS is 16 megabytes. All right, so I will search. Okay, so right, so this is my backup. Right, so I'll start all over again. So as you can see here, it ends at 09, as I said before. Right, so I'm going over to the downloaded file, and from here is where I actually made my selection. Right, so I'm going to press Alt G, and I'm going to go 60 megabytes. As you can see, it's already there. 5 Fs from the current position back from, and it ends here at the BIOS image right here at this Fs, right? So as you can see, the starting part of my BIOS here is Fs, all Fs, right? Means that it's blank, right? So it ends here. So I'm going to press Alt 2, and from here I jump again 60 megabytes. All right, so I'm going to jump back to 9090. All right, and from here is the ending, and I press Alt 2. Now I will save this as a new file, and this will be BIOS new.bin. Yeah, so I'm going to save. So as you can see, my now downloaded file, my new BIOS is actually the same size as the backup file, 60 megabytes. See, so my backup, and this is my new file, so they are both the same size. All right, so I will head back to the programmer, and I will program this new BIOS, and I will flash it into the ROM. So I'm going to hit right. Okay, so the flash is complete. So I'm going to head back over to the programmer. Alright, so I'm going under the microscope. YouTuber. Okay, so I'm going to test. Alright, so I'm just connecting the display here. Alright, so the machine is now partially connected. Alright, connecting the power. Partially assembled, sorry, rather. Alright, so I press the switch. Right, let me check if the switch is, yes, the switch is connected. Did I kill the power? Oh, sorry, I removed the power. Alright, so I'm pressing the switch now. See if I get something. Okay, so it's in a loop based on the current consumption that I'm seeing. I'm getting a loop. Try another RAM. Try another this slot again. CPU is very hot. Alright, so this slot is doing something different. The other slot, the current stock's at 800 milliamp. This one, all the current jumps in a sequence and it doesn't display. Okay, so I try another RAM again. Alright, I give power. Oh, on focus. Oh, there we go, we have a display. So the RAM was bad and the BIOS was bad because I tried several working RAM. Alright, I tried several working RAMs and they didn't work. So So the BIOS was corrupted, and we had a bad RAM as well. I'm going to clean them, the original RAM, with some with the eraser, and see if that solves the problem. Alright, so I think that's the end of the video. So I hope you learned something. I hope you like it, and I hope you enjoyed it. So I see you again in another repair video. Bye.